Welcome to the FMSP online revision. This session is for AQA M1. The topic we're looking at is Newton's laws of motion, and we're doing question 2 from June 2011. So just having a quick look at the question first of all. So we have a wooden block of mass 4 kilograms and it's placed on a rough horizontal surface. So just be aware that we've been told it's rough, so there is going to be friction. And of course we're then told that the coefficient of friction between the block and the surface is 0.3. A horizontal force of magnitude 30 newtons acts on the block and causes it to accelerate. So we've got 4 things to do. First of all, to draw a diagram to show all the forces. We've got to calculate the magnitude of the normal reaction force acting on the block and the friction force acting on the block. And then we've got to find the acceleration of the block. So if we just remind ourselves, then we were given, I've just put this information up here, we were given the fact that the mass was 4 kilograms and that the coefficient of friction is 0.3. We've got a diagram here, we were told it accelerates, so I've put a little arrow there just to remind us that it's accelerating in this direction. So when we come to look at part A, to draw all the forces, then we will have the weight of the block acting down, and its mass is 4 kilograms, so we'll have a weight of 4g. We'll have the reaction force acting upwards, we'll label that R, and then remember it was sitting on a rough horizontal surface, and so there is going to be a friction force which we could just label as F. So those are our forces. In part B now, we're asked to calculate the magnitude of the normal reaction force. So the normal reaction force R, if we think about resolving vertically, then R is acting upwards and there's no other force except the weight acting downwards, which means that R must be equal to 4g, in other words 4 times 9.8, which is 39.2 newtons. Remember, the unit of force is a newton. So we'll then move on to part C, where we're asked to find the magnitude of the friction. So what we need to know here and remind ourselves is that it is accelerating. So the friction is going to be at its maximum, and friction therefore will be equal to mu r. Now remember, we were told that the coefficient of friction is 0.3. We've just worked out the reaction force to be 39.2, and if we multiply those together we get 11.76, which we should just get into good habits of always giving our answer to 3 significant figures unless there's some other information or request. So part D then, we're asked to find the acceleration of the block. Now if the block is accelerating, then that means there must be a resultant force in the direction of the acceleration, and that resultant force will be the 30 Newton force which is pulling it along, minus this friction force which we've just worked out. Now again, we should take the value to be 11.76. We don't want to use the rounded value in this. And we're going to be using F equals ma, where F is the resultant force, is equal to m, the mass, which is 4, times a, the acceleration. So we're using F equals ma there, and so we can rearrange that to find the acceleration, and it works out to be 4.56 meters per second squared. So there were 7 marks in total for that question. If we just have a quick look and see where they were allocated, just one sort of statement mark here for getting a correct diagram showing all your forces. There was then also another B mark just for seeing that the reaction is equal to 4G, working that out. And then there was a method mark for using F equals mu r, and an accuracy mark for getting the correct value. And in the last bit, there was a method mark for using F equals MA, and an accuracy mark for following through using your value of friction. So it would have been a follow-through mark, that accuracy mark. So there were 2 marks for that bit, and then there was an accuracy mark for getting the 4.56. So you would have got 1 accuracy mark if you'd had the incorrect frictional value, but you wouldn't have got this one. So 7 marks in total. So don't forget that if you want to watch further revision videos, then you can go to the website, Further Maths Support Programme website, and follow the link to online revision.